All right, guys. So as I was saying now, we could have gone through this question using the angle at C, but it would require us to calculate that angle because that angle was not given in the question. But if we subtract 57 that was given, subtract 57 from 90, we would get this angle at C to be 33. And so we could also use this angle now to do our calculation. So we could use the tangent just the same. So we use tan of 33, and that would give us the side AB over BC. And so if we make X the subject, because remember now, the side AB would be X. So in other words, this would have given you tan of 33 tan of 33 would be equal to X, which is opposite, over the side, which is BC. So that would be 15. And now because we are making X a subject, we can move the 15 on this side and then multiply. And so we would get X is equal to 15 tan 33. And then you use your calculator, find the tan of 33. And then now you would multiply that by 15. And so your answer would be 9.74 as before. All right. So whichever way you choose to write this question, you would arrive at the same answer. All right, guys, moving along. I'm moving on now to an example of depression. All right, so here we have a question. It says a person standing on top of a cliff 50 meters high is in line with two buoys whose angle of depression are 18 degrees and 20 degrees. Calculate the distance between the buoys. All right, now the buoys are just some floating devices that they have out in the sea. Sometimes they may put lights on them so that they float to give ships light on the sea to know where they're going. All right, so a buoy is just a floating device. So a person is standing on a cliff, the top of a cliff, 50 meters high, is in line with two buoys. That means there are two buoys in the water. And that means if we looked at each of them separately, you observe an angle of depression of 18 degrees for one buoy and an angle of 20 degrees for the other buoy. So the first thing that you need to be able to do is to draw or construct a diagram for this. So who wants to walk me through in terms of constructing the diagram? Think about it, and if you're ready, just let me know. Raise your hand, guys. Just to check in, Miss Brown, are you able to hear me now?
Yes, sir.
All right, good. So Sam, do you want to walk us through this one?
Sir, my calculator is out of use.
Yeah, but we're just talking about the construction of the diagram.
Not as yet, sir.
Okay. Anybody else want to? Ms. Green, you want to try?
No, sir.
Ms. Brown, do you have any clue what we're doing?
Not one clue, sir. Sir, are you going to be posting the recordings?
Yes, I will try
I'll watch them then.
by tomorrow. The latest. All right, I have already posted all the ones that were done up to yesterday.
Okay, sir. I'll just watch this one when you post it tomorrow to understand more.
Okay, all right, no problem. All right, Mr. Lamar, do you want to walk us through this since you have an hang of what is happening? Just construct.
Yes,
Yeah.
sir.
All right. So tell me what we need to do here, Mr. Lamar.
Yes, sir.
Yeah, go ahead. So you read the question to yourself and follow what it is saying and construct a diagram to match what it is saying. So I say a person standing on top of a cliff. So if you have a cliff, you have to draw a cliff, right?
Yes, sir. Yes, sir.
All right, so we know that a cliff would be some level above either the ocean or something like that. So let's say that is our cliff. Now on top of the cliff,
Yes, sir.
you have a person. All right, so let me just draw the person and then Mr. Lamar will continue to walk me through this. I don't know who invents Stickman, but I guess it's the easiest drawing you can have. All right, make it into a graph. All right, now Mr. Lamar. So obviously what we are having here is somebody looking down in the ocean. So let me just give you some water down here. So we should have some waves or something. All right, the sea seems pretty rough. All right, continue now, Mr. Lamar. Tell me what to do.
Sir.
Yes.
Sir, can draw.
Yeah, go ahead.
Sir, can draw a slight line to resemble 18 degrees from the eyes down towards the sea.
All right, so first and foremost, we have two objects in the water, two buoys.
Yes, sir.
So we probably need to just make a diagram for the buoys.
Sir, right. But if you put it a degree line in first, like it can probably be more accurate.
Well, the drawing is not drawn to scale, so the accuracy of the angle would not
sir.
That important. All right. So let's
Yes,
say
sir.
this is one buoy right here. Oh, let me put it in the water. One buoy right there. Another buoy right here. All right, now, so what you say we can do now, Mr. Lamar?
So draw a line from the person's eye to the first buoy.
All right, so the first eye to the first buoy, that's one there.
Yes, sir. So one next line to the next buoy.
All right,
Sir,
continue, Mr. Lamar.
sir, draw a horizontal line from the base of the cliff.
From the base of the cliff. Remember what I said to you about the horizontal line? It must come from the line of sight, from the high side of the person.
Okay, sir.
Right, so the horizontal line will have to come from the eyesight of the person, just the same. All right, so let's say that this is our horizontal line. What do we want to know, find out now?
Sir, draw a vertical line from draw a vertical line from the buoys to the horizontal line.
All right, so you want to draw a vertical line from here down to here, that's what you're saying?
Yes, sir.
Okay.
Sir, you can draw another one to the horizontal line from this buoy. No,
Well, the one horizontal line would serve for both of them. Right, Mr.
Sir, repeat that.
I'm saying that the one horizontal line would serve for both of them.
Okay, sir. So now I try to find a distance between, sir, just I'll call it X from buoy 1 and buoy 2.
All right, so we're trying to find some distance. So let us use a different color. So let's say we are trying to find the distance X. Sorry, not the distance X, but let's label this as, let's call this A, buoy A.
Yes, sir.
And
Buoy B.
And the distance between them now, from A to B, is what we are calling X. So X is the distance between the two buoys. The distance from here to here is what we're trying to figure out. All right, what else do we know, Mr. Lamar? Put in our
Put in the
angle.
degrees, put in the angle degrees. Yes, sir.
Right,
And
so
the measurements.
tell me now.
All right, sir. So if you smaller one, you put in 18 degrees, and for the larger one, you put in 20 degrees. So we can't really show you. But
All right, so we're going
yes, sir.
to the horizontal line and we have two angles, 18
And 20 degrees.
So
Yes, sir. That one would be the 20 degrees.
horizontal line, we have one angle here.
And the other angle there.
And from the horizontal line as well, we have another angle here. So which is which?
Sir, the top one
Mhm.
80 is 20 degrees.
Top one is 20.
Sir, I find horizontal line, where do you find the line up? Sir, cause
From the horizontal line. Remember that the angle of
okay,
elevation.
sir. So if I horizontal line, the top one is 18 degrees, the second one is 20 degrees.
All right, so up here should be 18 degrees. And this one that meets this one down here should be 20 degrees. All right. Everybody following so far? What else do we know
So
about
then put in the 15 meter, the 50 meters
all
on
right,
the
so
vertical line.
height of the cliff? So we can put that here. And we know that it is the same height down here too as well.
Sir, but would the height of the person not play a role?
Yeah, we're assuming that the height of the person
I see
goes,
my height, I cliff.
goes height to the height of the eyesight. So the 50 start from the eyesight to the bottom there. Where they don't
Okay,
give
sir.
any height of the person, we're assuming that the person's height is included in the height of the cliff.
Okay, sir.
All right. All right, so how do we go from here now?
Sir, so what you're going to first, you're going to find the tangent of the 18 degrees and the 20 degrees, sir, and then you're going to subtract them.
The tangent of one and the tangent of the other. And then
Yes, sir.
so that's what you want to do. Where would you concentrate in terms of the triangles that you're using to do the calculation?
Sir, the line of sight and the vertical line from the buoy, that would be right angle. From right there.
All right, so you have two triangles that you can consider right angle. But remember now, the one that shows you the distance from A to B would be represented by
20 degrees.
it is represented by this triangle here. So we have to work with this triangle. I have to work with this triangle here because that's the one where the two buoys would have been some distance apart, right? So it means that the angle of depression that we have would be outside the triangle that we are working with. So if we are working with the triangle down here, one of the things that you should know is that are we dealing with just one right angle triangle or
No, sir.
all right, so here we have what we call a compound shape. Anybody know what compound shapes are? If you merge a square with a triangle, then you are putting two shapes together. So you get a compound shape. Now below we are working with two right angle triangles. So here's another right angle triangle. But they merge together. And so we have a compound. shape with these two triangles. All right, so you have a smaller triangle. If I should erase this line, you would recognize the bigger right angle triangle. Everybody see that? Raise your hand
Yes,
if you
sir.
recognize the bigger right angle triangle. All right, good. Now, if I should erase this line, you would have a smaller right angle triangle. Raise your hand if you recognize the smaller right angle triangle, guys. Everybody recognize the smaller right angle triangle, which is this one here. Everybody see this triangle that we are referring to?
Yes, sir.
Okay, all right. Now, so we are working with those two right angle triangles. And the two angles that we have for the depression are related to those two triangles. So how can we now get those triangles? Because those two triangles don't have any angle inside them. All you have is the angle of depressions outside. So we can get the angles inside by doing two ways in which we can get angles inside. We could use the property of Z angles. So if we use the property of Z angles, you could look at where you form Z. So this could be a Z. And so the angle up here, which is the 18, would be the same as the angle down here, which is also 18 for that Z angle. So we see that this angle would form the Z angle for 18. So down here is angle 18. And now if we have this angle, it means now that we would have an angle for the big right angle triangle down here. Now for this angle, the 20 degree become the Z angle for this angle down here. So this becomes 20 degrees. All right, so that's how we get angles now within these two triangles. Now that's one way of getting angles in the triangles. Another way would be we could use the angles above. If we wish, we could just find this angle up here by subtracting 18 from 90. And we could find this angle here by subtracting 20 from 90. But I would say that that is a harder way to do it. Use the angles below and you'll find that you will do less calculation. All right, so once you are able to put in the angles like that now, then now what we want to do is to construct our two triangles separately. Because they're overlapping, we want to see a clearer picture of what is happening. So I'm going to clear what I have here and continue with the question. All right, so here we would have our diagram. And we now want to separate the two triangles. Everybody see how we separate the two triangles? Raise your hand if you're following so far. All right, now based on what we have, we see that if we subtract BC from the length of the base of the smaller triangle, if we subtract that length from the other triangle, which is BD. So we subtract BC from BD, we'll get the distance D, or the distance X, as we were using before. All right, so from the smaller triangle, so D would be equal to BD minus BC. So from the smaller triangle, we could calculate what the length of BC would be. And then from the larger triangle, we calculate what BD would be. So based on this calculation, we see that BC would be 137.4 and BD would be 153.9. And so now to get the length D, we would now subtract 137.4 from 153.9. Is everybody following how we're getting that so far? So from the smaller triangle, we calculate this length here, BC. We calculate this length because we want to know this length. If we know this length, we could subtract it, right? So this is the length that we are subtracting. If we take away BC, then we are left with this length, all right? Everybody following so far? So from the smaller triangle, calculating BC, we get BC to be equal to 50 divided by tan 20. You could just walk through the process. So tan 20 is equal to 50 over BC. You bring up BC, bring down tan 20. So you get 50 over tan 20. Do that calculation with your calculator, you get BC equal to that. For the other triangle, we want to find the entire length, which is from B all the way down to D. So when we subtract BC, we are left with this length that we're trying to find, which is D. All right, so using the larger triangle, we see tan 18 equal to 50 over BD. Bring up the BD, carry down the tan 20. So we get BD equal to 50 over tan 8, sorry, bring down the tan 18. So we get BD to be equal to 50 over tan 18, which is work out to 153.9. Now CD is the same length that we're trying to find, which is D, or what we would have referred to as X, which is the distance between the buoy. So we have to subtract now from the entire length of this, we subtract this length, which is BC. So BD minus BC. We know BD would be 153.9. We know BC 137.4. So we subtract 137.4 from 153.9. And so we get our answer to be 16.5 meters. So that would be the distance here. So this distance would be 16.5 meters. That would be the distance for D. All right, guys, everybody clear on that? Raise your hand if you're following so far. All right, well, once you're following and it is clear, that is good, guys. All right, so I'm going to erase what I have here. All right, so we would have the other way that we could calculate it if we did the angles above. So for the smaller triangle, take away 20 from 90, we would get an angle of 70 inside. And the larger one, we take out 18 from 90, we get 72 on the inside. So we could use those angles too. All right. So if we're using these angles, so now we would use this side. We're still going to try to find BC, but we're using this angle. So now we would have BC over 50. So tan of 70 equal BC over 50. Then now we would just carry this across. 50 tan 70 equal BC. For this one, we have 72 here. So tan of 72 equal to BD over 50. We carry up this and multiply the tan 72, we get BD. BD equal to 153.9. So it's the same values that we're working with. Substitute it in the same formula. So this is D. So we are putting in the same values here. So we get 153.9, subtract 137.4, and we still get the same answer for D. So D is actually 16.5 meters. All right, guys, is that clear to everyone? Raise your hand. All right, so I'm going to stop here, guys. So we're a little bit over time. So I'm going to stop here and then now we'll continue with our lessons tomorrow. Now, as I mentioned before, I have already posted some worksheet for this trig ratios as assignment worksheet. So you can go and look at them and try work them, practice to work them, guys. You need to practice these. Don't ignore them because these are very popular in terms of exam. All right, guys, any question? All right, so I'm going to stop here now.